Hey folks, I wanted to go over some really important ideas of angles because in trigonometry, angles become increasingly important and it's kind of the cornerstone of what we talk about. So, what's different about trigonometry, perhaps from what you've seen before, is that angles are generally on an XY plane. So, what you normally have seen for graphing, also angles are going to be superimposed on top of these XY planes. We want to talk about different types of angles. So, you have positive angles, but you also have a possible negative angle, and I'll tell you a little bit about that today. And in particular, you want to know how to draw them and a few of the associated vocabulary terms. So here's a new vocabulary term, coterminal angles. And many angles, they land in the same spot. So these are angles that do that. They land in the same spot. Coterminal, they end. Co means cooperatively or two doing the same thing at once. Land in the same spot is where we want to think about coterminal. Okay, so let's get to angles. Now I have a few pre-drawn XY planes here. So here you've got X and here you got Y. And normally you think about these as the beginning of graphing. And what I'll just review here too is that this is 90 degrees that goes from here to here. So I'll write 90 goes from there to there. 180 degrees would be all the way from here to here. There's 180 degrees. 270 degrees, well, that would go around the bend like this and wrap around and hit right down there at 270 degrees. And then finally your friendly 360 degrees that comes all the way around and back again. All right, so we think of the X and Y axis as particularly important landing pads for your theta, and they're just multiples of 90 degrees going around. Now what's important is I always started here on the positive part of the x-axis. Notice that that's where each one of my angles started, and that's what we call a standard angle, is when it starts over here on the positive part of the x-axis. Notice also they all moved in this direction, and that's the counterclockwise direction. And that's what your angles that are positive do. They go in the counterclockwise direction. All right, well, you can also have angles that don't land on the x or y axis. So suppose I just take something and I sort of sketch like this and I go to here. That didn't land on the on an x or y axis at all. By the way, this vocabulary, where it does land, is called the terminal side of theta, and theta is a general, theta is drawn like that. It's a Greek letter, and generally we always use it to describe angles. So what if it landed in here, over here in quadrant 2, started here as a standard angle, rotated over here? Well, I'm just going to say that anything that lands in quadrant 2 area, that's any angle that's like between 90 degrees and 180 degrees. So if I went to here, I could kind of choose anything, but I'm just gonna say that, suppose that this is 120 degrees, and I'll say that that looks like it's about 120 degrees or somewhat close. So I've just given myself a quadrant 2 angle. Let's do this also for quadrant 3. Let's go in here and let's sort of sketch something that goes like this. Remember, it starts over here, comes around the bend, and it lands on the terminal side of theta. This is 210 degrees rotation. It landed in quadrant 3, and all angles that land in quadrant 3 will be somewhere in between 180 and 270 degrees. Okay, well, that was a quadrant 3 terminal side, and let's do theta terminates guess what? In quadrant 4. So let's let this guy wrap around, and I'm just going to go like this, say, and have it wrap around to here. And I don't know, that looks like maybe about 20 degrees beyond the 270. So let's call that 290 degrees where it wrapped all the way around to there. Again, this is the terminal side of theta. You should always draw the terminal side of theta. And everything that lands in quadrant 4 would, of course, be between 270 and 360 degrees. Okay, so that's kind of how you sketch these positive angles. And as I had said in the beginning, you could also have negative angles. So let's go back to a clean piece of paper. And now what we want to think about is negative angles. And these ones, they also start on the positive side of the x-axis, but they're going to rotate in the clockwise direction. So if something, see, here's the end, here's the terminal side, and I've drawn it, and I've drawn the angle and its direction with an arrow, and that's what you should be doing too. I'm just going to say that that's, suppose I'm trying to draw something that looks somewhat to scale. Say that's negative 30 degrees, and here's the terminal side of theta. Okay, so as I said, this thing is rotating the other direction. It's rotating in a clockwise manner. And also notice then that we might say that the angle is between negative 90 degrees and 0. All right, so this is a quadrant 4, right? So the quadrants all stay the same. That's still quadrant 4, and this is 3, this is 2, this is 1. This rotated in the clockwise direction, therefore it had a negative angle, and it does land in quadrant 4. Okay, now let's take a quadrant 3 angle. Suppose I just go like this. Well, you know, maybe that's something like negative 135 degrees. Now the magnitude of the angle just increased. That is from 30 degrees to 135 degrees. The magnitude increases. We go farther than in our clockwise rotation. What does that negative tell us? The negative tells us what direction it is rotating, and the 135 gives us magnitude of how far it goes. It's just going in this direction. It went past negative 90 degrees and rotated further another 45 degrees and ended up, well, it rotated another negative 45 degrees, and it ended up at negative 135, and I've drawn the angle. Let's have a look back at perhaps quadrant 2, and let's go like this, and let's let something rotate like so, and I don't know, maybe call that negative 210 degrees, and it lands back there in quadrant 2. Suppose that we had one that went all the way back to quadrant 1, and suppose it comes around here like this, and say then that this is negative, say, 330 degrees or something like that. Okay, so we've got this idea of rotation, and now let's talk a little bit about the idea of coterminal. So let me go back to this sheet right here, and let's look at the idea of coterminal. So what if they landed in the same spot? That's completely possible, correct? So suppose that I take the standard angle that starts over here on the positive part of the x-axis, but this one rotates clockwise. Suppose that it went like so. What angle would that be? Okay, well, look at how this was constructed. This went 120 degrees. If it went 60 degrees further, it would have landed at the 180 degree x-axis mark, right? So this one rotated negative 180 degrees and an additional magnitude of 60 degrees, and that lands us at negative 240 degrees if you do the arithmetic on that. Okay, so 180 plus 60 is 240. That's the magnitude, but the direction was negative, so we'll put a negative on that. Okay, let's come down here to 210 and let's talk about what would that be coterminal if I went in the other direction, the clockwise direction. So here what I would think about is, okay, I went past 90 degrees and basically look at how the full revolution would be 360 degrees. So if I said 360 minus 210, what do you get? Okay, so that must be negative 150 degrees. So there's a lot of different ways that you can see the value of the rotation. And the important part actually is that you draw it. So I would like to see you putting down a lot of drawings in this class so that you visually see what to do. I don't want you to go so much with formulas at all with this. I do want you to be able to draw something and see it. Okay, and let's go back this way. So suppose that we went back this way. 290 degrees is coterminal with negative 70 degrees, right? So if you wrote that out, it would just be, you know, something like 210 degrees is coterminal with, and then you give its coterminal of negative 150 degrees. Now, yeah, degrees are coterminal with a lot of other degrees, an infinite number of degrees. So also consider this idea. Let's just go back to this one right here. Okay, suppose we went to 120 degrees, and suppose then that we went around all the way around again. So again, suppose that I did this and I went to 120 degrees, but I went all the way around again, and then hit the same terminal side. That too would be coterminal if I went around, all the way around again. Well, what did we just do as a magnitude? We just went 120 degrees and we went around again. So if we add that up, it gets to 480 degrees. And so what we're saying is that 120 degrees is coterminal with 480 degrees. Oh, but it was also coterminal with negative 240 degrees, and it would also be coterminal with 840 degrees. Like, it goes on and on and on how many coterminal angles you have. There are infinite number of them. So let's go back down to this one here, and let's look at that. We already said that 210 degrees is coterminal with negative 150 degrees. But what if we went to here and we went all the way around again? What would that be? So remember how we said, well, you first went to 210 and then you went around the bend all the way around again. Let's add that up and we get 570. So I can also say that 210 degrees coterminal with 570 degrees. So, you know, we can also go around the bend even again, you know, why stop there and add it up and you get 930 degrees. I could say it also is coterminal with 930 degrees. And in fact, what I could just say is, you know, if I took 210 degrees and I added on any multiple of 360 degrees, any multiple of it, I got to give it a letter for that, say k, where k is any integer. So what I have is this expression to say all of these angles would be coterminal to 210 degrees. So that's the idea of coterminal. It says I land in the same spot. I could go around in a clockwise, that's a negative angle, or a counterclockwise, that would be a positive angle. I can go around multiple times. I get an infinite number of these. Okay, and that concludes our video on angles.